Hello? Hello? Are we ready to start? We're ready to start. Very good. Very good. Okay, so it's been a really great conference so far, but I'm hugely excited about this particular panel. We're joined by some of the rock stars, some of the titans of the SDMX community. They'll go through some enhancements, uses, and practical applications of the standard. So again, we'll break up the presentations. We'll have the first 3 presentations, followed by 5 minutes for questions. And then we'll have the following 4 presentations, and again, allowing some time for questions. So the conference has been excellent from timekeeping. So let's go. Abdullah and Matt, the stage is yours.
Yeah, thank you, Patrick. So good morning. I'm Abdullah Ghazalov here in Statistics Division. I'm joined by, we are making this presentation together with Matt Nelson from the PIS, and we'll talk about SDMX 3.1 and new features in SDMX 3.1. So one of the fundamental new features of SDMX 3.1 is support for highly dimensional data sets. So you have a data set that is highly disaggregated, right, which translates into multi-dimensional, highly dimensional data set. It is expected to have further breakdowns added in the course of use, and it will be used for both reporting and dissemination. So structures that are created in support of such data sets, they are often called horizontally complex, and we've seen that before. We've seen that actually this morning, horizontally complex structures, which you can think of as a table with many columns. And horizontally complex data sets are a problem. And they have been a problem for decades. Highly multidimensional structures are very difficult to implement in SDMX or practically in any other framework. Why? In the case of SDMX, every time you add a dimension to your data structure, existing data flows become incompatible with the new structure. What it means is that every time you update your DSD, you add dimensions, both reporters must update all of their mappings. And even if you are adding a dimension that is completely irrelevant to their own data flow, right? I mean, you are reporting a data flow for labor statistics, and somebody add a dimension on I don't know, let's say a type of disaster, which is completely irrelevant to your data flow. But you still have to update your mappings. You still have to update your data flow. That's how it works in the current version. So what it means is that when you release a reporting data structure definition, you try to collect as much information as you can on current and possible breakdowns, on whatever you have already and whatever is coming in the future. And that takes a very long time, which is why developing reporting data structures takes a very long time. And but even if you did have nearly complete information, even then, to cope with high dimensionality, you have to use workarounds. You can't. I mean, in the Sustainable Development Goals indicator data set, we have. I would struggle to even tell you precisely, but probably we're about 100 breakdowns altogether. You can't have a data structure with 100 dimensions, right? So even if you did have complete information up front, we would still have to use workarounds. And what do? Basically, you manage complexity by converting by trading horizontal complexity for vertical complexity. You replace breakdowns with you replace dimensions that could stand for all those breakdowns. You replace them with a single or a couple of dimensions that are mixed. So you have mixed concepts. You have concepts where a single concept implements multiple breakdowns, right? That makes the structure slightly easier to maintain and use, but they are still very difficult to use, those mixed concepts. They are difficult to use, they're more difficult to maintain than regular concepts, they're more difficult to use than regular concepts. So in the end, if you have a highly multidimensional structure, it ends up being quite dirty. And so as a result, what happens is that you have a reporting DSD that takes years to develop, and it's still difficult to maintain, and it's still you have to difficult to use, and it's a structure that is not really suitable for dissemination. It's very difficult to use for dissemination, right? So this is the frustrating situation that we have as of today. And what's interesting is this is not unique to SDMX. SDMX basically implements a so-called star schema. And star schema is used to represent multidimensional structures in relational databases as well. If you're building a relational database for your data, you'll have exactly the same issues. You can find another solution for them, but it will still be very difficult and frustrating. So what is new in SDMX 2.1? Well, what you can do in SDMX 2.1 is you can build data flows that target a slice of the hypercube, right? You can create a data flow that implements a group of indicators, let's say, with a group of breakdowns that apply to them. And these data flows, and data sets that correspond to those data flows, they stay valid even as you add dimensions to the parent data structure. Let's compare. In SDMX 3.0 in previous version, you add a dimension to the data structure definition, all existing data flows become invalid against the new structure. In 3.1 and above, you add dimensions to your data structure, existing data flows remain valid against the new structure. And I'm almost done, Matt. So the result is that basically in previous versions you were forced into a waterfall approach. You had to have a complete information. Here you can have an agile approach. You can start small and grow large. So it's really a faster and agile development of reporting structures. You can have clean concepts and code lists which are equally suitable for reporting and dissemination. And that means that you'll have an improvement in interoperability and usability and also reduced reporting burden. Over to you, Matt.
Thanks, Abdullah. That was really nicely explained. And I'll just try and explain from the technical side the changes that were made to the standards to kind of demonstrate how this behavior works. So starting from a very simple data structure definition, in the interest of keeping the slide simple, we have employment data structure definition with 3 dimensions. And in SDMX 3.0, as Abdullah has said, if I want to add or remove a dimension from this data structure definition, it will break the data set. So at the bottom of the slide, we see here a data set which perfectly conforms to the data structure. Adding a dimension would break the data set. So we have 2 choices in SDMX 3.0. We either create a new data structure definition with a new dimension, or we move to a new version, a new major version of the data structure definition, which is shown in this slide here. So you see the middle data structure definition has the same number of dimensions, but we've changed employment status to economic activity. And the last data structure definition, we just remove all but one of the dimensions just to demonstrate how this can work. How does this work in SDMX 3.1? So at modeling time, we start with our data structure definition, but we know that this is likely to evolve over time. We don't know how because we don't as Abdullah says, we don't know all of the breakdowns we're going to have in the future, but we know this is going to evolve over time. So we have this new property called evolving, and we set this to true. And what this tells us is if we want to construct a data flow for this data structure definition, we must fix at the data flow level the set or subset of dimensions that it uses from that data structure definition. So, and this is to protect the data flow from change. So in this instance, the data flow uses all of the dimensions in the version 1 employment data structure. But then as we evolve the data structure by adding this new activity dimension, we add the new activity dimension. The first data flow is protected from the change, and the subsequent data flows just cherry pick the dimensions that they use for their collections. And again, they're protected from change. So it's now adding data flows which can pick from a subset of dimensions from the evolving data structure definition. In the interest of time, I'm going to just skip a little bit forwards because there's only 5 minutes left. I have 2 more things to present in what's coming in SDMX. So that's SDMX 3.1, but the technical working group has also been working on new services, which I want to very quickly present in the next 5 minutes. And these 2 new services are to help make SDMX more compliant with the FAIR principles of open data. So the FAIR principles are data are findable, accessible, interoperable, and reusable. A critical step towards this was this URN resolver service. To explain what this service is, I'll first explain what a URN is. And a URN is a unique identifier for a structure. Every structural artifact in SDMX has a URN: code lists, concepts, concept schemes, data flows, data structure definitions. And the unique identifier is made up of 4 identifying factors. The first is what is the object. It's in this instance a data flow. The second part is who owns the object, the IMF. What's the ID of the object, the EXR, and it's version 1.0. This makes the URM. Every structure has one. What is the problem with a URN? It's not possible, or it was not possible, to take a URN and resolve it to the actual metadata resource, the official metadata resource, because there might be duplicates down to the last 3 minutes. We can now do this. So there's a URN resolver, urn.sdmx.io/resolve, put the URN in, and it will give you the actual artifact from the official source. So what does this give us? Well, the URN gives us stability because it never changes. And it allows URLs underneath to change. People may change their web service, but the URN gives us stability. This allows other standards to link to SDMX through the URN, and it has a permanence and stability. Now, the foundation of the URN resolver service is this other service I'd like to promote, which is the global SDMX Global Discovery Service. And this is fundamentally a catalog of SDMX compliant web service. It's a central catalog. So you can go here and you can ask, where's the IMF web services? Where's the ECB web services? Who has web services? And this is actually, this underpins the URN resolver. It uses this catalog to resolve the URNs. You can register as an agency for free your URL for your services into this catalog. And we encourage you to do so. And as soon as you register your service, actually the URN resolver then makes your metadata discoverable. Currently, it's a soft launch with just structure services listed, but we're looking to increase this for data services in 2026. And why does this matter? What's the business value? Well, number one, organizations can discover and reuse structures that are already out there rather than reinventing the wheel. And then sharing access to concepts between agencies makes it easier to combine data. And it also unlocks the visibility of where this information is. So together with the URN resolver and the SGDS, data becomes more discoverable, more reusable, and more fair. And I think I did it in time. So that's the end. Thank you.
Thanks, Abdullah. Thanks, Matt. Huge benefits outlined there, and as you said, you got through an awful lot in 15 minutes. I'll turn now to our colleague from the IMF, Alan, who's going to go through semantic versioning. Thank you.
Okay, so we got a little preview of this yesterday, so now we're going to talk sort of in depth about semantic versioning and sort of using it to unlock the power of 3 It says O in the agenda, but I was reminded by the presentation before me it's 3.12, right, so 3.x. So I'm not going to talk much about the URN. We just heard what this was, but what's important for us, what we're talking about in this presentation is that last bit of the URN, the version number. And in SDMX 3.x, there's two types of versions. You can have your sort of old-fashioned 2.0 version number, or you can have the newly available 3-digit version number, which is it must be semantically versioned. And the goal of this talk is to tell you why, going forward, you should pretty much always use the 3-digit number and try to avoid using the 2-digit number. So, first, a little reminder from yesterday. What is semantic versioning? Well, 3-digit version, each digit means something. If you're changing the first digit of your version number, it's a major change, not backwards compatible. A minor change would be backwards compatible. And a patch for a digit would be backwards and forwards compatible. And we also have this concept of an extension, which if it's present, your object can change. So this is a lot like the isFinal that we had back in SDMX 2.1. So now, why am I here talking about versioning? Why do I have 10 minutes? Well, because to me, this is the best feature, the best new feature in the past few years of SDMX, because it unlocks so many of the cool things that we've seen, some of the stuff that we just saw, some of the things that we've seen at the last global conference, some of the things that you'll see in the advanced capacity workshop tomorrow, right? So why is it so important? Well, because we can set up wildcard referencing. What does wildcard referencing allow you to do? Right, as we just saw, right, back in the day, you used to have to say, well, my DSD references version 1.5 of this code list, and if I ever want to update that code list, I need to go update my concept scheme, and then my DSD, and then my data flow, and it's a whole chain of sort of things that you have to do just because you want to update sort of one dependent artifact. So now with wildcard referencing, you don't need to do that. You get to say what type of changes are you willing to accept. I'll take all major changes, or I'll just take the minor changes, or I'm really particular. I'll take the patch changes. So, like I said, this enables the code list inheritance, which we didn't hear about today, but the evolving data structures, lots of other things, etc. Right? Time travels in the etc. If I got cool stuff like that, just in etc. There's a bunch of other cool stuff too. So, hopefully you're convinced. I want to use semantic versioning going forward, so I can take advantage of all these new features. And I guess our personal lesson at the IMF, right? We recently launched a new data management platform based on SDMX. Everyone says they want to be agile and they want an MVP, so we do that. We deliver them something without wildcard referencing, without semantic versioning, and what do we hear from our users? Why are we using SDMX end-to-end? This is crazy. I can't update my code list without updating sort of everything that depends on it. Should we rethink this whole project? And just wait a few weeks. We're going to have wildcard referencing. It'll be okay. This is really should save a lot of time and effort on your side. So, again, hopefully you're convinced. And you're asking yourself, okay, so I'm going to use wildcard versioning. I was half convinced yesterday. I'm all the way convinced now. So what? I'll just put a 0 after everything, and is that enough? I just get to pick what's a major change, what's a minor change. Do I have sort of complete flexibility? Or maybe I should just wildcard everything in the major version. Then I never have to think about it again, right? Don't do that, right? This wasn't in the standard. So we said, what's missing? What sort of guidance do we want to give people? we set up a joint task force between the TWG and the SWG to set up guidance on, what does a specific change mean? We heard yesterday the question about, geographic code list, I'm changing the shape. What sort of change is that? Well, it's in our documentation. What should I do with wildcard referencing? How should I migrate? I already have a bunch of SDMX artifacts that are in 2-digit. How do I migrate them to semantic versioning? So that was sort of our goals. And over the course of probably about a year, I suckered people in. I told them it was only going to take 4 meetings. I think we probably doubled that. So we came up with some general guidance around sort of any maintainable artifact. I'm changing the name of my artifact. What sort of changes that? Detailed guidance when you're changing the references between your artifacts. So this is all sort of documented nicely for you. We have artifact-specific guidance for each type of artifact. Every sort of action that you can do to that artifact, we've detailed if it's a minor change, a major change, a patch. We've given comments, things for you to consider when you're making this, right? Because you always have the flexibility. What we've said in the guidance is you always have the flexibility. These are the minimum required sort of version upgrades, but you can always, something that was a minor, maybe for you it's a major for some reason, maybe just because you want to. You have flexibility sort of to make it a larger change than it is required to be. And we also provided guidance on wildcard referencing. Don't just set everything to a major wildcard reference. You're probably going to have problems. So when should you use a minor? When should you use a major? When are there concerns? When are there not? We've detailed all that for each maintainable artifact. Guidance on migration, detailed guidance on, what are the steps to do. We have that too. So hopefully in this document we sort of can answer all your questions about how to do this. And so the next step, so again, everything's documented now. It's on GitHub. You can take a look. But right now these are sort of just like the rest of the content-oriented guidelines. These are guidelines. They're not part of the standard. So at this point, what's next? Well, what would be great is to have some feedback on the guidance. Where are things that we've sort of marked as major changes that are an issue for you, right? We just saw how adding a dimension is a major change. That created sort of some friction in this data collection exercise, so we needed a new feature, right? Are there other places where something being a major change creates friction? So feedback on the guidance, feedback maybe when you actually try to implement our migration strategy, you find something's missing and you want some guidance. So any feedback, appreciated. Going forward, we intend to sort of keep this updated as we get SDMX 3.2. We'll add sort of the additional changes there. We'll have a new version of this guidance. And what's really important is what we want is to get this guidance integrated into tools and integrated into the standard eventually. So the first step is to integrate it into tools. We would love the tool builders to not make their users guess that adding a code to a code list is a minor version change. We want that. We'd love to see all your tools just automatically version for people. That's what we do. We don't want everyone to have to go sit down and read all this guidance if we can avoid it. So hopefully tool makers can do that, and then the longer goal is to integrate this into the standard as well. Once we've received all the feedback, once everyone's happy, once we have some tools built against it, to really build it into the standard. Because if we have, if not everyone can support, for example, a major wildcard version at the data flow level, well, then when we're trying to reuse artifacts from a different institution against a different tool set, we might have problems. So all sort of agreeing on what are the allowed rules will sort of help with reusability going forward. So thank you. And there's our link.
Thanks, Alan. A very compelling case you made there. We'll now move on to our third presentation. So Yuri from the OECD is going to present on content-oriented guidelines for units of measure. So Yuri.
Thank you. Hello, everyone. So I'm going to present the work of the Units of Measure Task Group, which was tasked by the SWG to work on units of measures, and I'm going to give you a little bit of motivation why we think this work is important. But let me just list the co-authors of the guidelines. So Stefan Kret from StatsCan, Zlatina Hofmeister from ECB, and Anastasia Samsonova, my colleague at the OECD, were working on this project in several iterations. So to give you a context, the work was initiated by the Statistical Working Group, but it was preceded by plenty of discussions in this very community, in experts meetings and global DSD exercises. And most recently at the OECD, through our large-scale migration project to the new .stat suite, we have gone through hundreds of data models. And the unit of measure is omnipresent, and it really makes a huge difference if you do it right or if you don't do it right. So I think that because of the omnipresence of this concept, even though it looks like just one concept of the many possible concepts, it has a critical role in how your data warehouse works and in how you convey information to the data warehouse users. And so when we started the work, we could have launched immediately into designing code lists, but we wanted to take a step back and find ways of aligning ourselves when designing the guidelines and coming up with rules or recommendations. The first thing that became clear is that the best alignment is to just align with the metrology community, with the Système International for units of measures, because it's been there, it's proven. But then what we have noticed is that it's not even the standard that is so great, or the metric system, but it's the dimensional analysis and the way the whole system is constructed from base units. And this is something that we wanted to keep in spirit. And specifically in the dimensional analysis part of things, what we wanted to always keep in mind when working on unit of measure recommendations is what are the benefits? What did the Romans give to us when they invented the units of measures? And so it's two things. It's comparability, or kind of expressing what are the numbers within your data warehouse that you might potentially directly compare. That's what units of measures will do for you. If you have two numbers and they share the same unit of measure, you don't have a guarantee that you can compare them directly, but there is a good chance. And if you don't have the same units of measure, you should never compare those two numbers. You should first think and do conversions and analyze the referential metadata and the methodology, how the numbers were constructed. And so that weak contract is very powerful when you do units of measures correctly and systematically over your entire data warehouse. And then, of course, additivity is even less of a contract, but that's something, again, that comes with units of measures and some other properties of dimensional analysis. And so, I mean, we could have stopped there. We align with the metric system, and everyone should just work in that way in their data warehouse. But what we noticed is that there are some specificities in socioeconomic statistics that are not really captured in the SI system, and so we have to somehow relate to that. Currencies and monetary value is not expressed at all in those engineering and science-oriented systems. And then the other interesting element is the data warehousing context that gives a little bit of a kick to the way the guidelines had to be written. And so As I said, one of the most straightforward extensions is just to add monetary value as quantity and associate currencies with it. There are some complexities, and you will see the details in the guidelines on how you can extend the metric system, but it's fairly straightforward, I would say. And the only interesting element that comes along with the measurement of monetary value and derived quantities, it comes through in the next slide with the data warehousing element and the multiple dimensions that relate to monetary value. But one big area of numbers and units of measures that is not captured or it's kind of ambiguously recommended in the SI system is what we call measuring numerosity of sets, but it goes under many different names in the debates around units of measures. It's about counting quantities or measuring the number of entities or these names. The SI proposes two ways. If you measure the amount of substance, then you can use the mole as a unit of measure, and then if you work in a specific context, then you may add that it's molecules or atoms or some other small particles. But it doesn't work for anything else, and for the number of entities, the recommendation is to use just the number 1. And we felt that in our context, that's really not a good recommendation, because what it does, going back to the dimensional analysis kind of attributes or properties, it just switches off this capability of hinting to the user what is comparable and what is not comparable. Everything that you count under this recommendation becomes just a mush of potentially comparable data, but with no hints of what's truly comparable and what is not. And so the guidelines actually give you some guidance on how to find the right level of precision in labeling the entities and actually using them as units of measure. So you could have persons, enterprises, sometimes more specific things than sometimes less specific things than that. But in a way, it kind of extends the recommendations or modifies the recommendations from the SI system. And we have found some example even in engineering and science where people are kind of putting forward similar ideas and making similar recommendations in the direction. So that's an interesting element. I recommend you to read, and then if you still have feedback, try to let us know quite quickly, because the guidelines are quite close to publication. Okay, so then the data warehousing aspects. I'm running out of time, so I will try to be very quick with these ones. There are two main problems that stem from the data warehousing. One is, thank you. One is that units of measures quite often are captured on multiple dimensions in a data warehouse, and especially related to especially related to monetary value. And so I'm talking about the second bullet point here, or the second sub-bullet point of the second bullet point. And so usually we have the unit multiplier and currency and price base year. All these contribute to a proper unit of measure. And so the core here is currency, and in most cases it can go just alone, but sometimes we need to apply these modifiers. The guidelines will have some recommendations on how to decide how many dimensions should contribute and compose a unit of measure. But the other, the first sub-bullet point is probably the most challenging one, and it's unfortunate that I don't have time to give you great examples, but what I just want to convey as a message is that often when we compute ratios of things that have the same original unit of measure, we lose the unit of measure for the resulting quantity. And it doesn't necessarily have to be that way. In some context, yes, that's the perfect way to move, and that's what dimensional analysis in its narrowest sense would tell us. But every such calculation can be also interpreted as a change of unit of measure, where the denominator in that ratio calculation becomes the new unit of measure. So if you look at the example in the screen, the two numbers, 0.84 and 84% in the other part, is the same number. It comes from the same operation and the same calculation, yet you can decide in which way you put it in the database, whether you put it as a debt to GDP ratio in your database and with a unit of measure that is not existent or not applicable or null, or whether you put it as a percent of GDP. And what we are saying is that you should consider the unit of measure change approach more often than we have it done in practice, because it helps conveying the scope of comparability within the data warehouse and filtering out the commensurable data much better. And so moving on to my last slide, we have had an extended public review. We have received some nice comments, and we incorporated those comments into the 1.1 draft of the document. We are about to submit it back to the Secretariat, so if you got an appetite to reading the guidelines and you still want to sneak in some last-minute comments, then please do it very quickly, because the paper goes back to the Secretariat, and the Secretariat might approve it this time. And so, yes, but of course the work won't stop here. So we will have future revisions to the guidelines, and hopefully the task team, and if we have interest with an extended task team, we will continue working, and this time proposing code list or code list parts that could be then assembled into globally used units of measure code lists. Thank you.
Thanks very much. We don't have a huge amount of time, but we can take two quick questions, and I stress quick questions. So if there's any questions coming through. Going once. Okay. Oh, there's one here. Make sure it's quick.
Thank you, but I would like to ask a question after the first presentation on 3.1, 3.0 and 3.1. You will remember that when I was opening my presentation the other day, I used a slide on the standards which are changing. This was actually an old slide discussed with Arafan Gregory 15 years ago. We were dealing with 2.1. Standards change over time, there are versions. Changes always have some impact on the users. Users are not expected to always use the latest version. Standard setting organization must provide support for several versions of the standards. Now, I accepted the improvement with 3.1, for instance, how to dealing with multidimensional data to avoiding sparse cubes. It's very good and very bright. But what can we offer to the organization which have already done a great investment in adopting 2.0 and 2.1? Is there any support technically? I'm looking at Matt or Stratos or Wells, or from a more management perspective. I doubt that there can be a technical solution, because if a standard is a major change, it's by definition backwards incompatible. But what can we offer to countries so that they can adopt 3.0? So it's not a matter of SDMX adoption, but I would say adoption and migration. I said that I was not sure it's quick.
Okay, I'll try and make the answer quick by not saying much. The kind of 3.1, the TWG are trying to do kind of more minor releases to the standard where the changes are non-breaking. So 3.0 works perfectly in a 3.1 system, but you can just continue to use 3.0 DSDs if you want. 3.1 is just this new property and capability. What do we need to do? We need to release the tools. So things like the structural metadata repositories in order to actually allow countries to support this, agencies to support this in their systems. And then from a kind of technical perspective, we release the schemas now on xml.sdmx.org and json.sdmx.org, and we allow a kind of almost like a semantically versioning link, so you can always have your tooling refer to the latest versions of the schemas. So there's little things we're doing, but we're trying to keep the changes small. So we're moving away from a big bang approach of 10 years and there's a whole new standard. It's small incremental releases which are backwardly compatible.
Thanks very much, Matt, and thanks to all presenters. So we'll switch up again. Thanks very much. So the next three presentations all relate to microdata, and we have a combination of real-life applications and guidance. So the next speaker is going to be Alicia, who did some work, a novel preliminary attempt for retail trade indices. So whenever you're ready. Yeah, I'll get it for you.
Okay, can you hear me? Perfect. Hello everyone, I'm Alicia Nieto from Statistics Spain, and I'm going to talk a little bit about our current efforts while trying to standardize with SDMX 3.0 some microdata files. After a short introduction, I'm going to talk a little bit about the first steps while trying to learn the model. And then I'm going to explain how our internal microdata metadata system works. And then I will move on to the actual proof of concept. So in Statistics Spain, unfortunately, we neither have our metadata standardized or harmonized. That's the reason we're actually exploring standards for microdata. And that's the reason we explored DDI Lifecycle 3.0. We did a proof of concept, and now we're exploring SDMX 3.0. Parallelly, we are still struggling with data harmonization, you all know, but we are talking about a little bit about the standard part. So after the learning part, the trading courses that are already available and all of that stuff, we went just to search for SDMX 3.0 examples for microdata, and unfortunately we couldn't find them. That doesn't mean that there are no, I'm pretty sure that there are fully publicly available examples, but we couldn't find them, and because of that we tried, we had a look to SDMX 2.1 microdata examples, and that's when a PPP example comes in. And okay, the similarities between purchasing power parity and a retail trade index survey are almost no one. There's there's not something common, but we really needed to look at an example of 2.0 SDMX microdata with several variables, several measures, and that's why we analyzed this example. With this experience and these ideas and this inspiration, we then move on to have a look to the DSDs of BCI's Business as Consumer Service survey, which its retail trade index belongs to. because those two classifications, not classifications, but these two code lists that appear in the screen, in the slide, activity and product, do already belong and appear in the DSD for the aggregated part. So we really have to take them into account while doing the DSD and the data modelization through the microdata part, because it already appears in some parts. So after having a look to the DSDs for DSDs 2.1 example and the DSD of BCS, we went just straight to our microdata. Before doing the proof of concept, I'm gonna explain a little bit how our metadata system works. Well, what you can see here is an struct from an XML, Excel, it's an XML, but we've got our scripts to do the conversion between XML and Excel. And the intermediate steps after the data collection during the statistical process that are here remarked FG, FD, FF, the metadata of these three steps and these three files that are microdata are collected in one Excel file. That's the one you can see here. These extracts, this fragment, all the variables that appear are referred to the same concept, turnover. And we use qualifiers, this economic activity and region, to identify each variable itself, because it adds enough variable metadata information to identify each variable. So one whole XML, one Excel for the middle parts of the statistical process with the metadata condensed. Here's an example of how our microdata works with several with several variables. The 24 variables that I'm telling you that are related to turnover, here's the example. Some of them are for different regions and some of them for different economic activities. Well, with the first attempt we did, having this modelization in production, while trying to implement it in SDMX 3.0 was, okay, we've got 24 microdata variables, so we are going to establish 24 measures. Well, as you may guess, it's not a very well attempt. Daniel last year in Amsterdam told us, fortunately, because this is not maintainable. So we decided to define another data modelization. Now, all these turnover variables are not 24 measures, because that doesn't, as I mentioned, is not maintainable, but one, turnover. And this is the example of the N cube. And we continue doing exactly the same with the rest of the measures. And here's the final modelization that we already have. We've got all of that measures, several attributes. Imputation status that is remarked here is because it can take values from an array. That's something very 3.0. And those 5 dimensions that you can see there with the classifications that I mentioned in the first part of my presentation that came from the BCS DSDs. So, perfect. Okay, let's move on a little bit on the conclusion part. Well, we couldn't find examples. That's our first conclusion. I mean, I'm sure that there are a lot, but we couldn't find them. And then, as you may think, obviously, a lot of problems doing the data modelization part. Here, I wrote 2 examples. The first one is the fact that we already have in each file 2 IDs coexisting at the same time. That's a problem, because what's the solution? Defining two dimensions? There's no. One for one dimension and one attribute? No, because sometimes each ID it's an identifier. So we decided to put it one ID in the dimension list, and the other is a measure. and several problems while trying to do the data modernization. And I think I have time enough. The other example is that in the questionnaire is asked for the total turnover, and also it is calculated. So this type of things that each stakeholder for them is very, very important to take this into account and to not modify the structure and the data modernization. We really struggle to do it in SDMX 3.0. So also a conclusion that obviously it was a bit difficult and complex task to be done, but we really learned a lot, and it made our infrastructure far better than our first attempt. So that's it. Thank you very much.
Thanks, Alicia. Very, very clear and insightful presentation. We're now going to go over to Matthias, who's going to, from Statistics Netherlands, who's going to give us an NSO perspective on microdata modeling challenges in SDMX.
Thank you, Patrick, and nice to see you again. So this time I'm doing my own presentation, but the topic is the modeling challenges for use of microdata, particularly from the NSO perspective. Now, when I prepared the abstract for this, I wanted to describe the use case scenarios, the challenges and possible solutions. Oh, I think I will need the... However, after I learned that I have only 8 minutes, then I decided to drop the solution part, so I will only talk about problems. However, luckily, I have here my colleague Daniel, and we both, with many other colleagues, work in the cross-work group task force on microdata in SDMX, and he will cover that part of solutions. So, basically, the kind of business context for this is, in case of Statistics Netherlands, our data strategy, which has a vision that we should become more data-centric as an organization. So that means that we want to decouple the data from all sorts of silos that they are locked in at the moment. And also we want to create some sort of a better coordination internally, better ways to find the data, the right data, to describe it. So basically apply FAIR to also our internal data, not only for the data that we published, and also so to be in control of data, and also to connect to external data ecosystems. One example could be the AI use in the future, which also requires standardization. The reason why we are going for SDMX is, of course, our project that was already presented by Marco yesterday. So with the modernization of our data dissemination, we are introducing the SDMX, but it would be nice to extend SDMX a little bit further to the internal processes, because then you can kind of benefit from the shared information model and further enhance the automation. So if I'm now a little bit more generalize this from the NSO perspective, so data-centric approach requires standardized metadata across the data lifecycle. And in principle, SDMX has a potential to be used as information model, but we already heard from Alicia that there are some challenges. There are not many use cases where we could learn from, but there are some areas where this could be used. Yeah, I have listed some potential use case scenarios, but in our case, it's really about internal data infrastructure, kind of data lakehouse approach that we call data market. You know, in the Netherlands, each city in each town has a market on a market day. And you have like a fish stand, and you have, I don't know, clothes stand. So everything is like, regardless which town you go to, you will immediately know where you can buy something. And we would like to see something similar to our internal data. So in terms of this presentation, what I will try to do is to show modeling challenges with microdata on concrete use cases that we really have in our organization and on 3 different levels. So on the conceptual level, I already mentioned in my previous presentation a little bit like about that. So they are also in terms of microdata versus macrodata, some terminological challenges. For example, yeah, we tend to use variable term a lot in microdata world, and in kind of SDMX world, it's a dimension. We have challenges on the logical level because you need to document relationships between the data sets if they are microdata sets. And in kind of presentational level, there come complications such as sentinel values, the classification levels and stuff like that. And I'm not covering the technical level because that's not really probably a modeling challenge. So let's start with concepts. But what is microdata? And for that, I think we have a good definition as part of generic statistical information model. And it says that it's a set of observations or records which are pertaining to individual statistical unit. So that could be a person like me, and my microdata, so about myself, are actually in our databases in Statistics Netherlands because we use registers, but can be also companies and stuff like that. And here is the first problem that we came upon, which is that in the macro world, we often talk about population and statistical units, but what we really need for modeling is so-called unit type, or in some standards it's called object type, which actually defines that something is defined as a company or something is defined as a household. And at the moment, so this is well defined in the GSIM, but it doesn't appear in SDMX glossary, and also doesn't appear that there is a grid way how to store information about this object type in SDMX standard. So the second thing here is the difference how we define dimensions and primary keys in macro versus micro world. So at the bottom you have a very kind of simple and typical macro DSD or macro table, which has 3 dimensions and population count as a measure, very easy to define and document. Now, if we go one step back and look at the table that was used as a source to aggregate that population count, you can see that first, we are not sure what is now dimension here or what is measure. And the second thing is that we have a primary key defined in a different way. So in the macro world, the primary key is usually a combination of dimensions, while in the microdata world, in that case, would be we use pseudonymized person ID, which has two fields, but doesn't matter, could be one field. But it is not, it is not defined the same way as a dimension, but it's very important because it's the source for the next challenge, which is how to model relationships. Here is just the summary of modeling challenges related to concepts. I will not go through them. But I will go now to the relationships, so the second area that I want to cover. And in terms of relationships, I will use another practical example that we have, which is a survey on foreign subsidiaries. So we have two objects. One is company, one is foreign subsidiary, and we can see there is relationship, one-to-many relationship between the company and foreign subsidiary that we can resolve via primary and foreign key. This is very important for querying because we would like to know, I don't know, the data for subsidiaries only, or if I go to another example, households only. And at the moment, it is difficult to record the metadata about these relationships. Okay, so there are another couple of challenges. I would like to also mention the second one, which is actually opportunity. So if we manage to solve this, we could also describe structural data transformations such as micro to macro aggregations with the metadata, which would really help with our kind of process. Finally, the presentation level. So again, I mentioned sentinel values, but I will not go into that example. But there are also some specific differences with the way how classifications are used in the kind of macro data world. So usually in the macro data sets, you would pre-aggregate all classification of, hierarchical, all classification levels of hierarchical classification. So everything is kind of prepared and it's easy. Now, in case of micro data sets, what we usually do is we only use data, or we only store data in the data set for the most detailed level of classification. That will be the 4-digit level for ICD-10 that I'm showing here. And everything else is open, so you can aggregate ad hoc. So this, you can think about this as a schema on read versus schema on write. So micro data sets are still flexible to be used in all sorts of different ways, but that has sometimes challenges how to document them. Okay, so modeling challenges for this part are listed here again, so you can watch them later. And with that, I would like to pass to Daniel for solutions.
The slides? Now they're there. So we solved the first problem. The slides are visible now. This morning I created a lot of problems and Antonio solved them, and now I got a lot of problems, but I didn't have to solve them alone. So I'm speaking here on behalf of the cross-working group of microdata and SDMX. We are working now on a guideline for microdata modeling. Quite a while now, and I must say we have some progress and some achievements that I want to present today, and still work ahead of us that I want to show you. So not everything is solved yet. I can start with the good news. We can do it, and I will go a bit in detail how. And if you're interested, we can also speak later about even more detail, because I think I also have only 8 minutes, and it will take about 8 hours to 8 days to explain the whole background. To start quickly, so what was the objective? We wanted to have a seamless standard-based exchange of microdata, but not only the exchange was the trigger, but also, like also mentioned by the colleagues before from Spain and Netherlands, actually the internal modeling of microdata is even more relevant in that case, so that the exchange later on becomes efficient. To be interoperable across organizations, because we all have solved the microdata problems in our organizations, but once we hit the community, it's very difficult to be interoperable. So this is, of course, the mission of SDMX. And looking at SDMX as a standard for any data. With SDMX 3, we made this promise. We said, okay, we are onboarding now microdata. Already last year in the experts group, we discussed it, but now we had to kind of prove it with real use cases. So the objective is to deliver a guideline on microdata modeling, which is the first part of the journey, to start with the data models. I can already tell you what will not solve a lot of the implementation challenges that come after the modeling. We will continue working on that, of course, and there we rely also on you to collect good examples. But what we have started was with real-world use cases, so we did not start from a clean sheet. Mathieu has explained some of the challenges from CBS. We collected from there, and from many other organizations. We simply collected use cases and said, what's your problem? And we tried then to map it to SDMX. In some cases, we could solve it directly. So we said, okay, you can use multi-measures, you can use this or that feature that was there. But in some cases, it's more difficult, and we focus on those. There is not 100% coverage. We had this promise in SDMX 3.1, 2.3, but we still have some gaps that we find now when we want to practically use it. And we identified some issues. A lot of them are terminology, where we simply don't understand a feature because we call it differently, but also then in tools or in the standard itself. None of the gaps so far were blocking. so we can continue the work, but we needed to use workarounds or additional explanations that we will give in the paper. We have a very broad participation from central banks, statistical institutes, international organizations, so we believe we have a good base on which we draft the paper, but we will also tell you then once the paper will be kind of published, or we don't know the exact process yet, we will publish a draft probably quite soon, but then it is to challenge that paper with your real use cases as well, so that we can spread the word, and then maybe we can invite INER and we can invite CBS to really put it to the test and tell us if there's still remaining problems we didn't capture. What we're also doing is, so thanks to BIS, we have a Fusion registry where we are constantly working. If you scan the QR code, you will get the instance of SDMX.io, and under the agency CWG Micro, you find the examples. They will change every day right now because we are working on the paper. But also if you look at what I'm presenting, or if you look at the challenges we have as SDMX artifacts that are sometimes incomplete, that are sometimes not working, but this is part of us solving, but you can also follow the work through that. So looking at the what, so what will come out in the guideline, we have basically now structured the guideline in 3 chapters, the step-by-step modeling guide, and this week we reduced the 8 steps to 7, so it got even simpler, so the slide is already outdated. We agreed on Monday that we will have 7 steps, we will still see if they are enough, but let's say it's below 10, let's keep it that way, and above 3 steps to successfully model any kind of microdata domain, but some of these steps also linked into macro, like micro-macro linking was one of the challenges, so they are included in the steps. And then the challenges chapter would be a kind of how to solve a specific problem, and then point to the steps or point to the SDMX solutions, and the annex then listing the issues and then the categorization of issues using a traffic light system to say, okay, is it a real gap? Do we need to solve something in SDMX? And then we give it, Edgardo is sitting here in front, we'll just hand it to him or to the technical working group in that case. Edgardo was working on collecting these gaps and then documenting them for the technical working group to look into then solutions in the standard. Or we have workarounds, and workaround possible would mean we document the workaround and we'll use it, and we don't need to solve the problem beneath because we are happy with it. Or we use the workaround temporarily until the standard changes. We categorize that, and all good, meaning it's a challenge because maybe people didn't understand SDMX or didn't understand terminology, but we can explain it, and we explain it in the guideline, and the problem is solved in a green light. So when we look at the steps itself, I mean, you will recognize a lot of the words that Matthias has used in his presentation, right? So we go sequentially through. In a real project, modeling project, you might have some iterations and step back, step and forth, but there's a logical sequence. It's like to identify the entities, and now I'm using modeling language, let's say, a generic modeling language, not even SDMX language, because we needed to solve the terminology problem first. And we have a chapter where then we compare the terminology, where we say an entity in modeling is roughly a statistical unit in statistics, is roughly a concept or a category in SDMX. We're still looking at the exact representations, but basically we go then through identifying what entities are there. And you could see actually, before I was very interested in Spain, you went through the journey a couple of times, and maybe when we throw our paper at your problem, maybe we can speed it up and capture these lessons learned. Then once you have the entities, you identify them. So it would be in our world dimensions, but in the microdata world we heard before primary keys. So how can you identify the entities, how you can distinguish them? Then building the entity relationships. So how do they relate to each other? How does a household relate to a person, for instance? What variables are you collecting about the entities? Then the representation of those, so data types, code lists, and so on. And then you have the model more or less done, but then you talk about the transformation relationships, which is a different type of relationship that we also need to document. And then finally, we talk about data exchange and reference the metadata, which is something more classic. So we kind of now merged this step 7 and 8 in our latest draft. So that's why it says 8 steps here. In the latest draft, we have 7. We are still looking into that because the step 7 and 8 are more classic SDMX that we need to explain, but not microdata specific. So challenges, I told already. The good news is we didn't find a blocking issue so far. The main discussion actually, and it took us a lot of meetings to discuss terminology, we have put now a table together that we are working on as part of the paper. We'll put it in the annex most probably to simply compare terms, and also on the terms then to show, is it a real problem? So does the term mean the same? Or is it simply to understand the SDMX term and then translate it to your world and simply use it, even if it doesn't sound intuitive, you can use it and it's working. So also in the terminology, we then give a mapping between the terms high level, but enough then to finalize the modeling and understand the model. So some examples we got from Matjaž before, like what is the difference between dimension primary key? In the model they look the same, but in reality they mean something completely different. Or what types of relationships do we have, or what is one of the challenges we heard from Spain before, what is an attribute, what is a measure, why is it what, and how can I decide? Yeah, so to summarize, we are working now on the guidelines. We are based it on real-world use cases, but we can never have enough. So it's also then for you as a community, if you follow our work a bit, once we have a draft paper available, we would ask also you to try use it, to give us your use cases. We have discussed to put complete use cases into the paper, but that will take too long. So our idea currently is that we will then have white papers where really the guidelines are applied in these use cases that we would do after the guidelines are published. So we'll throw it back to CBS to solve their problem with the paper. We'll throw it back to some of the other members in the group then to issue kind of annexes or cite white papers that we can publish later to say this is how it's used in practice. So we have done now the documentation of the use cases, the documentation of the challenges, the documentation of the gaps. We are now writing the guideline up, doing formatting, doing text. It's also not so simple, but we have a draft. We consult it in the group. We'll consult it with the community once it's ready. This is the current phase, and then once that is done, we throw the paper back to the technical working group, we throw the paper back to the statistical working group to maybe work on additional guidelines that are missing, to correct guidelines from the past that are not anymore relevant or correct, and then maybe also to solve some technical problems in the information model. This is the work going forward, I think, which will happen after the cross-working group is finished, then to give it back then again to the community to work with it. So with that, thank you very much, and back to the chair.
Thanks very much, Daniel. You got through some amount there, so take a break after those 8 minutes. I think just in regards to the three presentations there on microdata, we really see real collaboration in action there. You know, different use cases, but similar core problems, and the different people working together to come to solutions. So it's very, very positive. The last presentation in this set of presentations today is relating to a maturity model for SDMX adoption. And I suppose after all the presentations this week, it might be a question you might have for your own institution or for yourselves, where you are in terms of SDMX adoption. So really looking forward to this one. So David, take it away when you're ready.
Okay, thank you, and thank you everyone. So this is a presentation on the maturity model for SDMX adoption. And it's produced by a task force that is working on, looking at how to implement SDMX at the enterprise level, so a kind of strategical level. So I haven't got a slide that lists the working, the task force members, but Petra, she's our chair, so thanks a lot, Petra. But there's several of us here that are in this task force. So the problem statement. So I guess the first problem is that I'm the last presentation, and even on the the handout, you may not see that there is another presentation because I'm in the next page. But here goes. So SDMX adopters, they want to achieve the best value for money and interoperability and integration when they adopt SDMX for certain use cases. Okay, so we really went with a use case driven approach, rather than just saying, okay, the use case is to implement SDMX, because that's never really the use case. You don't want to like save money or something like that. However, for this, there's very little reference material, or maybe there's no reference material. So how to do it is in some of our heads, but I think it's in some of our heads quite differently as well. So at least in this task force, it allowed people who have experience of this to actually like talk through the issues and agree. But so the main goal is to list what we perceive as common use cases, but to agree on the best practices and approaches, and to produce a maturity model, which is what I'm going to show. But it's not the only thing coming from the task force. Okay, there's like I guess the working name is this like cookbook to see to describe the detail in the maturity model and how to implement, and other things to do with that strategical approach. Abdullah mentioned enterprise modeling, things like that. Okay, so the goals of the maturity model itself. So you can use it to ascertain an agency's readiness to implement certain use cases, which I'm going to come to. Okay, so the idea is here, maybe think again if you want to try to solve a use case, but you haven't done such and such, because it may take you a very long time, or you may just be kind of wasting money or something. Also, know where to focus resources and effort to actually best implement these use cases. In a certain extent, know what to do at a strategical level, and I guess to a lesser extent, if you want to measure your agency's maturity in SDMX implementation, you can use it as a kind of scorecard. So yeah, when I say agency, I mean it in a very generic sense. So whether you're an organization or an agency or a company or whatever. So just to speed through some of the main use cases, but these are not all the use cases, right? But and we're going from a very low to a kind of high. So maybe the lowest end, you just want to you have some data and you want to convert it to SDMX for providing to an international organization. Okay, so, because they're hassling you to give them something in SDMX format, or maybe they're forcing you to do it. So yeah, you use a tool to do this, and usually it's very low complexity. We're not talking about any modeling or harmonization here, we're just simply converting data to SDMX. And then next thing is something like, using a tool to validate some data and to look at it. Okay, this is again very low. All right. Also, then going up in complexity. Now you're going to create a DSD. Okay, so you got some data. You're going to create a DSD for it. This needs certain things to be in place, for you to succeed in doing that. Publishing data via APIs, another kind of level again. Collecting data and reusing it. Okay, thank you. Yeah, and going up, so improving management of structural metadata, harmonizing data. Again, now we're getting really into quite complex things. It says medium there, but I know that this is actually quite complex. So, and then integrating your statistical production. Okay, now we're getting even more kind of costly and time-bound things. And on the last end, it's like integrating AI. I think we put this as last one because it's still a kind of unknown country, right? So it's very much a kind of moving target. So we split the maturity model into certain dimensions. We grouped it into two groups. So you got like on the one hand, like business and institutional setting, things like executive support. Making sure that you have the executive management funding and sign-off to do these things. You have IT resources. You have communication and capacity building behind the implementation. Things like structural metadata governance. And then on the other side, you have the data architecture dimensions, such as structural modeling, harmonization, which is actually different to modeling, right? I mean, you may like model everything, but not harmonize it. IT knowledge, tools knowledge, and processes and workflow. So certainly not going to read all of this out, but then, so those were the dimensions, right? And these are the actual maturity levels. So on the one hand, you've got initial awareness, which are things like just a few people are like aware of SDMX in the first place. Management may just not be aware, or okay, thanks. Or essentially, yeah, have very little kind of involvement in it. Pre-implementation, so people have started to become aware, and analysis has started, etc. Early implementation, so you've done some things in production, but it's not kind of corporate-wide. Corporate implementation, yeah, okay, so it's used throughout the company, but there's maybe some silos like remaining, and then mature is like, okay, now everything is kind of done, and you have like a full funding and etc. So what we did is like we took the use cases here in the rows, and we mapped it to the maturity, to the dimensions, and we said in each cell what is the level of maturity that is required. So you can see for basic data set publication, which is the least complex, you know, everything is initial apart from tools expertise. So you need some tools expertise to ascertain which tools you're going to use to actually do this, right? And the same thing for local data viewer and validator. But then we go up to something like publish harmonized data sets, and now you start to have a spread of things where your structural modeling needs to be mature, and harmonization you know, is corporate, so it's just like one step down, but you need to be at the corporate level before you actually try to harmonize your data sets. But you're probably thinking, well, what the hell does that mean? But then you have to look at the detail in the maturity model. So the, yeah, thanks. So here we come to like just a couple of use cases I tried to kind of sketch out. So using a standard to structure data. So we're still at like the early complexity stage, and yeah, a lot of text. I'm sorry about that, but I did what I could. So we can see that to use a standard like SDMX to structure the data, then you at least have to have some senior managers being aware of the SDMX benefits, right? It's no good like starting to do this and you got just like no backing from management. And there needs to be like an estimation of resources, so that's pre-implementation, sorry. So, and looking at the structural modeling dimension, so yeah, I mean, you need some stuff like knowing how to structure data, right? I mean, all this sounds obvious maybe, but you know, you don't want to start to structure data when people have like, you know, no structural modeling expertise. And then looking at something like about IT resources, well, maybe you don't need so many IT resources, right? You know, this is like structural modeling is more on the kind of subject matter side, so we put that into initial. So, but then looking at something like publish harmonized data sets, which is like a medium complexity, but actually quite a lot of complexity, then to publish harmonized data sets, then the governance has to be mature. Why? Because it's very difficult to harmonize data sets with no notion or little notion of how you're actually going to like look after those data sets after you've done it. Okay, you have to know who's going to be responsible for what, and this really should be decided before you harmonize your data sets. Okay. Yeah, just one other thing here, you know, and then tools expertise. Yeah, you need to know which tools you're going to use for the harmonization, and you know, things have to scale in IT resources, things like that. So yeah, sorry, I haven't got time to kind of read more of this and to discuss it, but yeah, that's what it looks like. So this is my final slide. So some questions as a kind of conclusion. You know, so how do I implement these details, right? Like executive support, etc. Well, there'll be like supporting material to the maturity model to show how to do this. Okay, the maturity model stays at a very high level and just tells you, you know, like what kind of like situation you need to be in. And when can you use the maturity model? Well, we aim to publish it at the end of this year, all being well. I mean, it's still at a draft stage, okay? So, you know, the things that I've shown is still kind of in flux. And how does my agency score? Well, yeah, that's very interesting. So you're welcome to have a look at the maturity model and maybe, you know, do this analysis. But the main aim is to see how to implement the use cases in the best way possible, you know, value for money, etc. And just a final point, you know, now when we have the maturity model, we need to communicate on it really, because, you know, a lot of effort has gone into this. Maybe I'm biased, but I think it's very useful. But I just hope that when we publish it, then it actually becomes visible, so people can actually refer to it. So we need to do it in a good way. So yeah, that's it. Thanks.
Thanks, David. The previous chair spoke about keeping people from coffee. I'm really conscious that keeping them from their lunch might be even less popular. But I'll open it up for 2 questions, if there's 2 questions. Yeah, Brent.
Eric Anvar from OECD. I have a question for Alicia. Could you explain in a way the goal you're pursuing? Your data is available already in DDI, so why would you remodel it in SDMX? So just perhaps I didn't misunderstood.
We did a proof of concept with Retail Trade Index in DDI Life Cycle 3.0, and we repeated the same proof of concept with the same, you know, Retail Trade Index survey. They are neither, none of them are already in production in those standards. They're only proof of concepts to put one just next to each other and see the comparison.
Yes, very quick question, but let's say a strategic question. Investing a lot in 2.1, and for the next 2 years to invest in terms of tools, do we have to move step by step, invest in 3.0, 3.1, or directly jump to 3.1, or wait 3.2?
You happy to take them out, or?
I mean, that's a good question. So 3.0, I think, was an example of quite a large release, right? Because there's a long period of time between 2.1 and 3.0. So 3.0 is a really good starting point. And we're seeing the features implemented in the tools like the FMR with, you know, semantic versioning and DSDs with multiple measures and things like this. But these point releases, 3.1, 3.2, they're kind of identifying specific use cases like horizontally complex DSDs, specific use case. In 3.2, we're looking at custom structures for things like presentational metadata. So really the decision starts to become, does this actually satisfy needs that we have within our organizations? But we're seeing this starting to be rolled out into the tools like the metadata repositories. So then the question becomes more, perhaps, how do we then use these features in our user interfaces, or how do we use it in our data warehousing? And that becomes a...
Yes, if I can add very quickly, look at your use case and make a decision. If your use case is reporting of highly multidimensional data sets, then yeah, wait for 3.1. Doesn't make sense to go for 3.0. If your use case is dissemination and you already have clean data structure definitions that would benefit from, let's say, codeless inheritance, then there's no need to wait for 3.1. So it should be a practical decision.
One single addition. 3.0 changed the way of modeling data. So it's a really, let's say, tough decision to move to 3.0, but necessary. But it will have effects on the way that you model your data. 3.1, 3.2 add features that you may need it or not. But in any case, tools will incorporate these features and it will be adding, but will not change the way that you model your data or the way that you use SDMX. If you don't need, don't put that. But if you don't need to add more dimensions horizontally, or you don't need, you will not be affected by incorporating 3.1 or 3.2. But changing to 3.0 is let's say, backwards incompatible change, and this is why it is 3 major versions and not a minor change.
So we'll take one last question. Yeah.
So the last presentation talking about the maturity levels and maturity models. So I don't find any convergence between these two because the versions are keep on changing the maturity. Because the first level itself, we have to convince the top management once we reach a level of maturity, then where the version stands. Then again, we have to think of the another version. So how the convergence? That's my question.
Sorry. I mean, so if the question is like, how do you get the buy-in from the senior management? Yeah, the maturity model itself doesn't tell you that. Yeah, this will be the supporting material. Now, we have something on that from the task force, but we're still kind of finalizing it. So I hope that this will be something that will be produced as part of the task force, you know, in the kind of implementing SDMX at the enterprise level. Okay, but we haven't got that yet, so we haven't published it yet. Is that okay? If not, we can discuss it outside, you know, because I think we're out of time. So.
Cool. Thanks, David. I'm conscious Raphael wants to give a few quick updates, but before he does, I'd just like to applaud the members of the presentation today.
So for the capacity building, there were still a few people who asked, can I join, can I switch the room? So Yamil and Jonathan, they will be at the registration desk. Please, if you want to change something or you want to join, they will tell you how many we can actually accept in addition. In addition, maybe you can just move one slide back. We were actually spinning up a new Wi-Fi here because of the Slido issues we had yesterday. So that's a new Wi-Fi connection. This is should only be used from your mobile for the upcoming Slidos. We have actually 3 in the pipeline in the afternoon. If you don't manage this, we will show it again later. So please, I give you just 10 seconds to click that. So. Maybe 20 seconds. If you don't manage to connect, then at the registration desk, the colleagues also have the password. So you just go to the registration desk. Okay, so I see most people connected, so we can move to the next slide. So this is another QR code. This is again for the registration for the SDMX lab, because still we see that not all of you have actually created an account, and this is a prerequisite for the capacity training. So you see on the left side there are a few instructions, and on the right side you can actually get directly to the registration. So take a picture of the slide or the QR code now. And if there are any issues, again, on the at the registration desk, you will get support. Now, just as a heads up, we will change a little bit the timing in the afternoon because we have one presentation less. So we thought actually that we do the panel discussion right after the session after lunch. So we move the coffee break right to the end, and then with the finish of the coffee break, basically the conference is finished. So the coffee break will be around 4 o'clock. So just as a heads up already for you, that you know there will be some changes. So there was a question whether for the capacity training you need a computer and laptop. The answer is yes. And then just for the secretariat members, there will be a meeting of the secretariat at 1 o'clock in the room next here. So then enjoy the lunch.